Hi students, so I am continuing with the exercise 7.2. So continuation of the exercise 7.2. So we have done up to the exercise question 22, up to 22 question. The next question is sine inverse of x divided by square root of 1 minus x square. We need to find the integral of this one. So how did I start with the solution? That is, first I will take I is equal to integration of sine inverse of x divided by square root of 1 minus x square dx. So since the method you can clearly see, we can substitute here. So what I can write here, I will put sine inverse of x as is equal to t. Then I will differentiate this one with respect to x. So what is the differentiation of sine inverse of x? It is nothing but 1 divided by square root of 1 minus x square, and differentiation of t with respect to x is dt by dx. So it becomes for dx divided by square root of 1 minus x square is equal to dt. Now I will substitute this sine inverse of t and dt in this equation. So what happens, I have considered sine inverse of x as is equal to t, and dx divided by square root of 1 minus x square, it has become dt. Sorry, not it comes it becomes t dt. Okay, so because this whole part I have considered it has dt, so it becomes t into dt. So integration of this one, it is nothing but what? So it is nothing but t square divided by 2 plus c. So what is the value of t here? Value of t is nothing but here sine inverse of x whole square divided by 2 plus c. So this is the integral of the given question. The next question is 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x. So first I will consider this one as I and take it as I is equal to integration of the given integrand into dx. So now here starts with the substitution. So before moving into the substitution, just look into the question how I can simplify this thing, all these things. First we should get that idea by looking into the question. So what I can see here is in the denominator we are having 2 as common. So if I take that 2 common from the denominator, means what we are going to get, it is nothing but 2 cos x minus 3 sin x divided by, if I take 2 common outside from these two terms, by taking 2 common outside here, remaining it is nothing but 3 cos x plus 2 sin x into dx. So this is what the remaining. So now our I, we are considering this one. So now again starts with the substitution. What I am going to take here, I am going to put what? 3 cos x plus 2 sin x as is equal to t. After taking that one as is equal to t, I will differentiate this one with respect to x. So after differentiating this one with respect to x, what happens here? Differentiation of cos is minus sin x, 3 is a constant as it is, plus 2 constant as it is. Differentiation of sin is cos x, which is equal to t differentiation with respect to x is dt by dx. Now you can see here clearly 2 cos x minus 3 sin x. If I bring this dx towards the left hand side, it becomes into dx is equal to dt. So now I am substituting this value of t and dx in the given above equation, that is 1 by 2 integral. So I have taken 3 cos x plus 2 sin x, this one as is equal to t, and you can see here 2 cos x minus 3 sin x into dx, this one we got it as dt. So now we know the clearly the integral of dt by t, it is nothing but 1 by 2 log of mod t plus c. So now again resubstituting back the value of t, that is what is the value of t, it is 3 cos x plus 2 sin x. So it becomes 3 cos x plus 2 sin x plus c. So this is the integral of a given question. Our next question is 1 divided by cos square x into 1 minus tan x whole square. So first I will consider this one as I and integrate and call it as I. So before proceeding or before going to the substitution, just watch into the question carefully, what the alteration or what the rearrangement you can make in the question, so that the question, solving the question becomes more and more simpler and easier manner. So you can see here we are having tan x, so differentiation of tan is secant square x, but we are not having any secant square x, but we are having 1 by cos, and we know that 1 by cos is secant, so 1 by cos square x becomes secant square x. So all these ideas should flash into your mind by looking into the question. So what I'll do, 1 by cos square x, I am writing it as secant square x divided by 1 minus tan x whole square dx. Okay, now I will consider, now I will go with the substitution, because now you can see here clearly we are having 1 minus tan x, and the differentiation of tan is secant square x, we are having secant square x, so we can deal with it. So what I will do, I will put 1 minus tan x as is equal to t. So by taking 1 minus tan x is equal to t, and then I will differentiate this one with respect to x, means what happens, differentiation of 1 with respect to x is 0, differentiation of tan with respect to x is secant square x, here minus is there, it is carried out, so minus secant square x is equal to differentiation of t with respect to x is dt by dx, so it becomes secant square x into dx is equal to minus dt. So we got the value of t as well as dt regarding to this question. So what happens, secant square x dx, that is nothing but minus dt, and 1 minus tan x, I have substituted it as t, it becomes t square. So I will take the magnitude outside, that is minus 1, so it becomes dt divided by t square. So I can write it as what, minus t to the power minus 2 dt. So now it is in the form of integration of x power n dx. So x power n dx integration, it is nothing but x to the power n plus 1 divided by n plus 1 plus c. So in place of n we are having minus 2, it becomes what, in minus t to the power of minus 2 plus 1, it is minus 1 divided by minus 1 plus c. So minus into minus, it becomes plus, so 1 by t plus c. So what was our t here? Our t was 1 divided by 1 minus tan x plus c. So this is the integral of the given question. The next is cos of root x divided by root x. So first I will consider this one as I and take the integration. So now we need to do the substitution. So by looking into the question itself, we will get an idea. We are going to put root x as is equal to t. So if I put root x as is equal to t, and then our next step is we differentiate this one with respect to x. So by differentiating this one with respect to x, differentiation of root x is 1 by 2 root x, which is equal to differentiation of t with respect to x is dt by dx. So our 1 by root x, if I bring dx towards the LHS, means dx divided by root x, which is equal to 2 times dt. So now we got the value of t and this one. So I'll substitute these two in this equation. So it becomes what, cos of root x, I have taken it as equal to t, and dx by root x. So dx by root x, it is equal to what, it is equal to 2 times dt. So by taking the constant outside, what we are going to get, cos t dt. And we know that integral of cos is nothing but what, it is nothing but sin t plus c, which is equal to 2 sin, we are resubstituting back the value of t, it is nothing but root t. So 2 sin of root x plus c. So this is the integral of the given question. The next is cos x divided by square root of 1 plus sin x. So here also we should think before we are substituting what we are going to substitute. As I said, we are having the derivative of cos x, which is sin x in the question itself, and the derivative of sin as cos in the question itself. But the approach of idea, it should be thought of. See here, sin which is having between inside the roots, and here cos, it is in the numerator. So we should think about before substituting. So what I will substitute here is, I'll put 1 plus sin x as is equal to t. Then I will differentiate this one with respect to x. So what happens? Differentiation of 1 is 0. Differentiation of sine is what? Differentiation of sine is cos x. And differentiation of t with respect to x is dt by dx. So it becomes what? Cos x dx, which is equal to dt. So now we got cos x dx as is equal to dt, and we have taken 1 plus sin x as is equal to 3. I am substituting these two in this equation. So what happens? Cos x dx, it has become dt, and I have taken 1 plus sin x as is equal to t, it becomes root t. So what happens if it becomes root t? I can write it as t to the power minus 1 by 2 dt. And we know the formula. By the formula, integration of t to the power minus 1 by 2 dt, it becomes what? T to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus c. So it is nothing but t to the power 1 by 2 divided by 1 by 2 plus c. So if I bring this 1 by 2 to the numerator, it becomes 2 t to the power 1 by 2 plus c. I am resubstituting back the value of t. What was our t? It was 1 plus sin x. So it becomes 2 into 1 plus sin x to the power 1 by 2 plus c. So this is the integral of a given question. The next is square root of sin 2x into cos 2x. So first I will consider this one as equal to I. Then again it goes with the substitution. So what I need to substitute, that is our idea. So what I am substituting here is I am putting sin 2x as is equal to t. Then I am differentiating this one with respect to x. So what is the differentiation of sin 2x? It is cos 2x into differentiation of 2x, it is 2. It goes with the chain rule. Then differentiation of t with respect to x is dt by dx. But what we required by looking into the question, we required cos 2x into dx. So I'll write cos 2x into dx. I'll bring this 2 to the right hand side. It becomes dt by 2. So we got the certain things which we are needed to substitute in the given equation. So it becomes what? I have taken sin 2x as t. It becomes square root of t. And we got cos 2x dx as is equal to what? That is dt by 2. Now what I will do? I will bring that 1 by 2 constant outside the integral. So it becomes square root of t dt. So I can write this one as 1 by 2 integral t to the power 1 by 2 dt. So integration of this one, it is nothing but t to the power 3 by 2 divided by 3 by 2 plus c. If I bring this 2 to the 3 by 2 to the numerator, means 2 get cancels, it goes with 1 by 3 t to the power 3 by 2 plus c. So what was the value of t here? The value of t is sin 2x. It becomes 1 by 3 sin 2x to the power 3 by 2 plus c. So this is the integral of this question. The next question is cot x into log of sin x. So first I will consider this one as equal to I and integrate this one. The next thing is which one we need to substitute. So look here carefully. Here we are having cot x and we are having log of sin x. So think it. If I take log of sin x as equal to t, what will be our derivative? If I take cot x as is equal to t, what about our derivative? Think about it. So clearly if I take cot x as is equal to t, we are going to get the derivative of cot x as what? Minus cosecant x into cot x. So clearly we are not having any such terms like that in our thing which we going to get by looking into log of sin x. So I am thinking about taking log of sin x as is equal to t. If I take log of sin x as is equal to t, then if I derive this one with respect to x, means what is the derivative of log of sin x? Derivative of log is 1 by sine x, and derivative of sine is what? It is cos x, which is equal to differentiation of t with respect to x is dt by dx. Now you got cos by sine. Cos by sine is what? It is cot x. If I bring this dx to the LHS, it becomes cot x dx is equal to dt. So now I got this one as our dt and this one as our t. By using these two, I will substitute in this above equation. So what I got, log of sin x, I have taken that one as equal to t, and cot x dx, what I got, cot x into dx as is equal to dt. So now I got integration of t dt, and we know the integral of this one, that is nothing but t square divided by 2 plus c. So what is the value of t here? The value of t here was log of sin x. So 1 by 2 log of sin x. So log of sin x whole square plus c. So remember using these braces properly. So if you miss this braces and write it in the improper way, even though up to here if your answer is right, if you misses this bracket and the square is not satisfied like what I have written, means then simply you will lose the 1 mark. So while using this bracket, use it properly and make it meaningful for your answer. The next is sin x divided by 1 plus cos x. So I will take this one as I first and then goes with the substitution. So clearly by looking into the substitution, now I hope upon solving all these much of questions, you might got the idea what you need to substitute. So I am substituting here 1 plus cos x has is equal to t. Then I differentiate this one with respect to x. So differentiation of 1 with respect to x, it is 0. Differentiation of cos with respect to sine is what? It is minus sine x, and differentiation of t with respect to x is dt by dx. So now in the question you will see here, we people required sin x dx. So what happens? Sin x dx, if I take it as per the requirement from the question, this minus I am bringing this towards the right hand side, it becomes minus dt. So now I am substituting t and dt thing in the our above question. So what happens? Sin x dx, I got that one as minus dt, and I have taken 1 plus cos x as is equal to t. If I bring that minus outside the integral, we got dt by t. And we know that dt by t, it is nothing but what? It is nothing but log of mod t plus c. So what was our t here? Our t was log of mod 1 plus cos x plus c. And this we have the identity, that is m log n is equal to log of n power m. So by using this identity, what happens? I can write this one as log of mod 1 plus cos x to the power minus 1 plus c. So what does that implies? Log of mod 1 divided by 1 plus, sorry, mod is not going for whole thing, it going for only this one, 1 divided by 1 plus cos x plus c. So this is the integral of this given question. The next is sin x divided by 1 plus cos square x. So first thing I will take that one as equal to I, that is sin x divided by 1 plus cos x whole square dx. Then going with the substitution, I will put what? I will put again 1 plus cos x as is equal to t. Then I differentiate that one with respect to x. So by differentiating this one with respect to x, differentiation of 1 is 0, differentiation of cos is minus sin x, and differentiation of t with respect to x is dt by dx. So from the question we required only sin x dx, so keeping that one and moving rest to the RHS, we are going to get sin x dx as is equal to minus dt. So now I am substituting all these things in the above equation. It becomes sin x dx, it becomes minus dt divided by, it becomes, I taken 1 plus cos x as is equal to t, it becomes t square. So if I bring that minus outside the integral, means dt divided by t square, I can write that one as t to the power minus 2 dt. So by using the formula, it becomes what? T to the power minus 1 divided by minus 1 plus c. So this minus into minus, it becomes plus 1 by t plus c. That implies what is the value of t? Value of t was 1 plus cos x plus c. So by resubstituting back the value of t, we got 1 divided by 1 plus cos x plus c. This one has the integral of this given question. The next question is integration of sine cube x into cos square x dx. So from here it starts with we need to think some bit more than the previous questions up till now we have solved. So we are having sine cube x into cos square x dx. So before substitution, think about it how we can simplify these questions so that the substitution becomes much and much easier. So what I am doing here is we are having sine cube x. So I am writing that sine cube x has sine x into sine square x into cos square x dx. So I have splitted this sine cube x has sine x into sine square x, and we know that, and clearly we know that what? Sine square x plus cos square x is equal to 1. So that I am substituting now for here, simplifying this sine square x has what? 1 minus cos square x. So what I will do next is I'll keep this sin x as it is. In place of sine square x, I will substitute it as 1 minus cos square x into this cos square x. I will keep that one as it is. I will write like this. So here I have substituted sine square. In the place of sine square x, I have just by using the identity of a trigonometry, I have written like this. Now we are having the given question like, that is sine cube x into cos square x dx as sin x into 1 minus cos square x into cos square x dx. So now at this stage I will do the substitution. So what I am substituting here is I am going to take, or I am going to put cos x as is equal to t. So by taking cos x as is equal to t, and then I am differentiating this one with respect to x, means the differentiation of cos. What is the differentiation of cos? The differentiation of cos is minus sin x, and differentiation of t with respect to x is dt by dx. So here we are having sin x as well as dx. So what happens? Sin x dx is equal to minus dt. So now I am substituting these things in the above equation. So what happens? 1 minus, I have taken cos x as is equal to t, it becomes 1 minus t square. This becomes t square. Combining cos x and dx, we are having combining sin x and dx, we are having sin x dx is equal to what? Minus dt. So now we got all these things. Now I am bringing that minus outside the integral and multiplying this t square to both the terms. So by multiplying this t square to both the terms, it becomes t square minus t to the power 4 dt. So by knowing the algebra of integrals, I will write t dt. This minus is for both the term. So I will use the big bracket here. So minus integral t square dt minus integral t to the power 4 dt. So by using the algebra of integral, this dt is used for both the terms in this integral. So by using the proper formula, that is integral t square dt, it is nothing but t cube by 3 minus integral t to the power 4 dt, it is nothing but t to the power 5 divided by 5 plus c. So now what happens? If I resubstitute back the value of t, what is the value of t here? It was cos x, so cos cube x divided by 3 minus cos to the power 5x divided by 5 plus c. So multiplying back that minus, it becomes minus cos cube x divided by 3, minus into minus plus cos 5x divided by 5. If I multiply this minus to the c, it becomes minus c, again minus c, it is a constant. I will take minus c as equal to big C, it becomes plus c. So since it is a constant, I have represented in this manner. So this is the integral of the given question, that is what, sin cube x into cos square x dx. So here in this question, these two steps matters a lot, where you are rearranging the given question in such a way that the simplification or the substitution of that question becomes much and much easier. So it is not a direct feed. Here you need to alter the question, alter the things in such a way that it becomes much easier for you people to digest and get the answer. The next is we need to find the integral of sin x divided by sin of x plus a dx. So here alteration, all these things doesn't matter, because here we are having sin x, sin of x plus a. So this is another way of solving. So here what we are going to put here, x plus a as is equal to t. Then if I differentiate this one with respect to x, means what happens, it becomes differentiation of x with respect to x, it is 1, constant it is 0, which is equal to dt by dx, it becomes dx is equal to dt. So now what happens, I is equal to, since I have taken x plus a has is equal to t, this implies x is equal to what, t minus a. Since the independent variable here it is x, so if I am turning this one into the independent variable in terms of t, means all the terms should be in terms, all the variables should be in terms of t itself. So what happens here, integral sin x, I can write x as t minus a, it becomes what, sin of t minus a divided by sin x plus a, I have taken it has t, and we got dx as is equal to dt. So we got integration of sin t minus a divided by sin t into dt. Now we know that, what we know by looking here, we know the formula of sin a minus b. So what is sin a minus b formula? Sin a into cos b minus cos a into sin b. So this is the formula of sin a minus b. So I am using that formula for sin t minus a, where a is t and b is a. So what happens by using that formula, sin a minus b is equal to sin a into cos b minus cos a into sin b, okay, divided by sin t. Clearly a, it is constant here. Here whatever the variable a is there, that is constant. So what happens, cos a, it is a constant, because we are going to get cos a, means what it is here, if a is some real number, means cos of that real numbers we are going to get some value, this becomes constant. So what happens, we are having two terms in the numerator, I will split it. This sin t is belonging to both that terms in the numerator. So what happens, sin t into cos a divided by sin t dt. So here you should write dt. If you didn't write in any step, means it is going to be negative marks for you people. So cos of t into sin a divided by sin t dt. Okay, so now what happens, clearly sin t get cancels, integration of cos a dt minus here cos by sin is what, it is nothing but cot t into sin a dt. Now clearly cos a, it is a constant, sin a, it is also a constant. So I am bringing that constant outside the integral. So it becomes cos a integral dt minus sin a integral of cot t dt. Now let us integrate this one. Cos a integral of dt, it is nothing but t itself, minus sin a. We know that integration of cot t, or integration of cot x is what? Integration of cot x is log of mod sin x plus c. So what happens? Integration of cot x, it becomes log of mod sin t plus c. Okay, so this c I am using it for whole. This c and the c which is going to get here, that is I am going to combine the two and I am using that c as a whole here. Okay, what happens if I resubstitute back the value of t here? What was the value of t in the beginning? I have taken t as x plus a. What happens? Cos a into x plus a minus sin a into log of mod sin t. In place of t I am substituting it as x plus a plus c. So this is the integral of this given question. So the thing or the agenda what you need to remember here in this type of question is, you are taking x plus a as equal to t and using the identity at this stage, that is using sine of t minus a, you are using the identity sine a minus b. Then further simplification, it goes with the along with the step of an integration or general steps. The next question is, we need to integrate dx divided by 1 plus tan x. So here the simplification of the question matters a lot. So I can write tan as what? 1 plus sin x divided by cos x. So if I take the LCM, cos x is the LCM. So what happens? Dx divided by cos x plus sin x divided by cos x. So if I bring this cos x to the numerator, it becomes what? Integration of cos x dx divided by cos x plus sin x. Now further simplification is required to solve this type of integral. So what we are doing here is, first thing, we are having cos x divided by cos x plus sin x dx. So first I will multiply and divide by 2 here. So what happens? 2 cos x dividing by 2, 1 by 2 cos x plus sin x into dx. Okay, so what happens? 2 cos x, so 2 cos x, it is written as like cos x plus cos x, right? We are writing it like this, cos x plus cos x into cos x plus sin x dx. Okay, then in the numerator I am adding and subtracting the sin x. So if I add and subtract the same thing, there is no changes in the numerator. So 1 by 2 cos x plus sin x plus cos x minus sin x divided by cos x plus sin x into dx. So I have added the sin x and subtracted the sin x in the numerator. Now I will group these two terms as one and these two terms as another. Now we are having two terms as per the brackets. So what I will do, I split the denominator to both these terms. What happens? 1 by 2 integration of cos x plus sin x. This denominator is for both the terms, so it becomes cos x plus sin x into dx plus, and this 1 by 2 is for both the terms, so I am using the big bracket here so that we are not going to get any confusion. So what happens? The next term, integration of cos x minus sin x divided by cos x plus sin x dx, closing the big bracket. You can see here the numerator and denominator both are same, it get cancels. So what is remaining in the first term? 1 by 2 integration of dx plus the next is integration of cos x minus sin x divided by cos x plus sin x into dx. I am calling this one as I1. This was our I and I am calling this one as I1. Now I am considering I1. That is what? Integration of, I'll call this one as star. So it becomes cos x minus sin x divided by cos x plus sin x into dx. Okay. Now we are going with the substitution. So what I am going to substitute here is I am going to put cos x plus sin x has is equal to t. So now I am differentiating this one with respect to x. So the differentiation of cos is minus sin x and differentiation of sin is cos x and differentiation of t with respect to x is dt by tx. So it becomes cos x minus sin x. If I bring this dx to the LHS, it becomes into dx is equal to dt. Now we got the value of t and dt. We are substituting that one back in this equation. It becomes what? Cos x minus sin x into dx. I got that one has t and I have taken cos x plus sin x as is equal to t. And the integral of this one is nothing but log of mod t plus c. I am resubstituting back the value of t. The value of t was cos x plus sin x. It becomes cos x plus sin x plus c. So this is the value. I am calling this one as c1. Okay. And this becomes log of mod cos x plus sin x plus c1. This is our equation 1. Now I am considering another one, that is integration of dx. So integration of dx is x plus c2. I am calling this one as equation 2. Now I am substituting 1 and 2 in the equation star. So what happens, our equation star I is equal to in 1 by 2 big bracket integration of dx. What we got? Integration of dx as x plus c2 plus then integration of cos x minus sin x divided by cos x plus sin x. I have taken that one as I1 and I got I1 as what? Log of mod cos x plus sin x plus c1. I have got like this one. Now what I do? I multiply this 1 by 2 inside the bracket. X by 2 plus 1 by 2 into log of mod cos x plus sin x plus c, where this c is equal to what? c2 by 2 plus c1 by 2. So which is both constant. So I am combining all those constant and giving one value, that is has equal to c. So now this is the integral of the given question. So what was that question? It was integral dx divided by 1 plus tan x. So all the three questions which I solved right now, this is one question is this one, another one is this one, another one is that is what? Sin cube x into cos square x. All these three questions are very important because all these three questions are solved in the examples, which is much more different from the example exercise questions from the 7.2. So these are very important. You can expect these questions for your board examination also. So please understand all these three type of question and work it on it. If you have any doubts with these three type of questions, you can ask me at any time. The next question is integration of 1 divided by 1 plus cot x dx. So this is similar to the previous question which I have solved. So it goes with that method itself. So first thing, I can write this cot x as what? I can write that one as 1 plus cos x by sin x into dx. By taking the LCM, I am going to get sin x plus cos x divided by sin x, and moving that sin x to the numerator, it is going to become sin x divided by sin x plus cos x into dx. So the next is I am multiplying and dividing the 2 to this question. So it becomes what? 2 sin x 1 by 2 integration of 2 sin x divided by sin x plus cos x into dx. So that now I am adding and subtracting the cos x to the numerator. So it becomes what? 1 by 2 sin x plus cos x plus sin x minus cos x divided by sin x plus cos x into dx. Then I am grouping the first two terms and the next two terms in one way, so that now I am splitting this integral. So it becomes 1 by 2 big bracket integral of sin x plus cos x divided by sin x plus cos x into dx plus integral sin x minus cos x divided by sin x plus cos x into dx. So here sin x plus cos x get cancels, and we are going to get 1 by 2 integral dx plus integral sin x minus cos x divided by sin x plus cos x into dx. So what I am doing right now here is to get the answer as per our need. What I am doing here is, that is, I am taking the minus common outside from the numerator. So what happens? Minus, so minus, if I take an outside, means it becomes minus sin x, and this becomes plus cos x. So that I can write cos x minus sin x divided by sin x plus cos x dx. So this is as per our convenience regarding the thing. So now I am calling this one as equal to I1. So now I am considering I1, that is integration of cos x minus sin x divided by sin x plus cos x dx. So what happens now? I am going to do the substitution, that is I am going to take sin x plus cos x as is equal to t. Then I am differentiating this one with respect to x. So differentiation of sin is what? It is cos x. Differentiation of cos is what? Minus sin x is equal to dt by dx. So if I bring this dx to the LHS, it becomes cos x minus sin x into dx is equal to dt. So now I am substituting these terms in the above equation. It becomes what? Cos x minus sin x into dx. I got that one as equal to dt, and I have taken sin x plus cos x as is equal to t. So the integration of this one is nothing but log of mod t plus c, which is equal to log of, substituting back the value of t, it is nothing but sin x plus cos x plus C1. I am calling this one as C1. So I got the value of I1 as is equal to C1. I'll call this one as equation 1 and this one as stub. And this one I am considering integration of dx. This is equal to x plus C2. I am calling this one as equation 2. Now I am substituting 1 and 2 in the star. It becomes what? 1 by 2 x plus C2 minus of log mod sin x plus cos x plus C1. I got like this as the answer. Now I am multiplying this 1 by 2 inside this bracket. It becomes x by 2 minus 1 by 2 log of mod sin x plus cos x plus c, where that c is equal to C1 by 2 plus C1 by 2 plus C2 by 2. I am calling that one as equal to 2. I am calling that one as equal to C. That is right, C1. I call this one as C2. C2 by 2. This minus is for both the terms, so it becomes what? Minus C2 by minus C1 by C2 plus C2 by C2 by 2. This one I am calling it one as C. So this is the integral of the given question, that is what? 1 divided by 1 plus cot x into dx. So similar to this type of question, there is a next exercise question, that is integration of 1 divided by 1 minus tan x. So I am leaving this question to do it by yourself, so that by practicing you also get some ideas. So this one, do it by yourself. If you have any doubt regarding the solution of this question, you can ask me at any time. I will help you with the solution of this question if you didn't get the answer of this one means. The next question is integration of root of tan x divided by sin x into cos x dx. So before using the substitution, we should think about the question and we need to do some arrangement in such a way that the substitution part becomes much and much easier. So what is that part we are doing right now here is root of tan x. To the denominator, I am multiplying and dividing by what? Cos x. So what happens, multiplying and dividing by cos x, it becomes sin x by cos x into cos square x to dx. So multiplying cos x, it becomes cos x into cos x, cos square x, and it becomes divided by cos, sin by cos, it comes like this. So now you can look here carefully. Root of tan x divided by sin by cos is tan x, and this one is cos square x into dx. So what we got now, integration of root of tan x into tan x, it becomes what? Tan x to the power 1 by 2 minus 1, and 1 by cos. What is 1 by cos? It is nothing but secant square x dx. So what happens now, this one, tan x to the power 1 by 2 minus 1, it is minus 1 by 2 into secant square x dx. Now in this stage we are going to do the substitution, because by looking here itself we have clear idea that we have the derivative of tan x in the question itself. What I am going to put? I am going to put tan x as is equal to t, and then I am differentiating this one with respect to x. Differentiation of tan is secant square x is equal to dt by dx, which is equal to secant square x into dx is equal to dt. Now I am substituting back these things into the above equation. It becomes tan x, I have taken it as t to the power minus 1 by 2 into secant square x dx, this one is equal to dt. Now what happens, by the formula it is becomes t to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus c. So it is nothing but t to the power 1 by 2 divided by 1 by 2 plus c, which implies 2 into t to the power 1 by 2 plus c. Bringing this 1 by 2 to the numerator, it becomes 2. So what is the value of t here? The value of t, what was that? It is tan x. So it becomes what? Tan x to the power 1 by 2. It is nothing but square root of tan x plus c. So 2 into square root of tan x plus c is the integral of the given question, that is root of tan x divided by sin x into cos x. So this is the integral of the given question. The next question is, we need to find the integral of 1 plus log x whole square divided by x dx. So by looking into the question itself, we can do the substitution here. I am going to take 1 plus log x as is equal to t. Then I am differentiating this one with respect to x. So what is the differentiation of 1 with respect to x? It is 0. Differentiation of log x is 1 by x, and t with respect to x is dt by dx. If I bring that dx to the LHS, it becomes dx by x is equal to dt. So now we are having the value of t and dt. Substituting back in the above equation, it becomes what? 1 plus log x, I have taken it as t, it becomes t square, and dx by x, it is equal to dt, so it becomes t square dt. So we got t square dt. By using the formula, it becomes t cube by 3 plus c, and resubstituting back the value of t, it becomes 1 plus log x to the power 3 divided by 3 plus c. So this is the integral of the given question. The next question is, we need to find the integral of x plus 1 into x plus log x whole square divided by x into dx. We need to find the integral of this one. So here, by looking into the question, think and do the substitution. So what here is, I'll write this x plus log x whole square one side and write this one together, x plus 1 divided by x dx. So what it happens, x plus 1 x dx, so x plus log x whole square, x by x it is 1 plus 1 by x dx. Now you can see here properly the differentiation of x with respect to x, it is 1. Differentiation of log x with respect to x is 1 by x. So we are having the derivative of this thing here itself. So what I am going to substitute here, I am going to put x plus log x as is equal to t. Then I am differentiating this one with respect to x. So it becomes 1 plus 1 by x is equal to dt by dx. So it is nothing but 1 plus 1 by x dx is equal to dt. So we have got the value of t and dt here. Substituting all those things in this above equation, I have taken x plus log x as is equal to t. It becomes t square and this whole term is going to become tt. So integration of this one is nothing but t cube by 3 plus c. So what is the value of t here? Resubstituting back the value of t, x plus log x whole cube plus c. So 1 by 3 into x plus log x whole cube plus c is the integral of this above question. So certain times by looking into the question or the length of the question, we might get tensed how to solve, but think properly here. The only thing is that you need to do this arrangement. This matters a lot to solve this question. So sudden idea of getting this thing is mattering a lot while solving these type of question. So here this is the question. By looking into the question itself, I hope you people might get the idea. We are going to take here tan inverse x power 4 as is equal to t, and now differentiate this one with respect to x. So we know the differentiation of tan inverse of x. Differentiation of tan inverse of x is what? 1 divided by 1 plus x square. So it becomes what? 1 divided by 1 plus x square. Here x is x to the power 4 whole square. Then again we need to differentiate. Chain rule, differentiation of x power 4. It is nothing but 4x cube, which is equal to dt by dx. Look into the question. We are having x cube 1 plus x power 8. So here it becomes what? 1 divided by 1 plus x power 8. X cube is there. 4 I am not required in this question. So I am bringing that 4 to the RHS and bringing this dx to the LHS. It becomes dt by 4. Now we are having certain things. We are substituting these two terms in the above equation. We are going to get what? Sine of, I have taken tan inverse x power 4 as is equal to t, sine of t, and we got x cube divided by 1 plus x square dx as is equal to what? Dt by 4. So taking the constant outside the integral, we got 1 by 4 integration of sine t dt, and we know that integration of sine t dt is nothing but minus cos t plus c. It is nothing but minus 1 by 4 cos, what is the value of t here? It is tan inverse x power 4 plus c. So this is the integral of the given question. So these are the questions from the exercise 7.2 regarding how we are solving or getting the integral of certain functions through the method of substitution. By using the method of substitution, how we are going to get the integral of certain functions. So this is regarding the exercise 7.2. Go through each and every question's solutions properly. Get an idea. Practice only gives you the clear idea. By solving it once, you are not at all going to master in any of this trigonometry, integration part. You have to do a continuous practice. So practice only will lead you people to understand each and everything clearly and properly. That's all, guys. So this is for regarding the today's class. If you have any doubts regarding any questions, means you can ask me at any time. Thank you, guys.